extrinsic semiconductor. Okay, we will be, what in the case of extrinsic semiconductor? Extrinsic semiconductor means here we are doing a doping. Okay, in extrinsic semiconductor we are doping. Doping means addition of impurity. Doping means addition of impurity. Okay, addition of impurity. Now, in the case of extrinsic semiconductor, we have two type of doping. First is P type and second one is N type. P-type semiconductor means there we will be adding trivalent impurity, and in the case of N-type we are having pentavalent impurity. Okay, so in the case of extrinsic semiconductor, I am writing, in the case of extrinsic semiconductor, we have P-type and N-type. P-type means trivalent impurity. And N-type, and in the case of N-type, there will be pentavalent impurity. There will be pentavalent impurity. Okay. Now, in the case of trivalent impurity, the electron will be minority charge carrier. Let's see that thing with the explanation. Okay, in P-type there will be trivalent impurity. What do you mean by trivalent impurity? There will be group 13 elements. What are group 13 element? Yes, boron, aluminium, gallium, indium, and thallium. Okay, now, and what in the case of pentavalent impurity? In the case of pentavalent impurity, we will be having group 15 element. What do you mean by group 15 element? N, nitrogen, phosphorus, arsenic, antimony, and bismuth. Okay. Extrinsic semiconductor means doping, addition of impurity. There are two types of extrinsic semiconductor. First is P-type, another one is N-type. In P-type, there will be addition of trivalent impurity. In the case of N-type, there will be addition of pentavalent impurity. In the case of trivalent impurity, we will be having group 13 element. In the case of pentavalent impurity, we will be having group 15 element. What do you mean by group 13 element? Group 13 element means boron, aluminium, gallium, indium, thallium. And in the case of 15 element, we will be having nitrogen, phosphorus, arsenic, antimony, and bismuth. Okay, now let's see the first case. The first case we have is of P-type. Okay, in P-type, what we have? In the P-type, we have trivalent impurity like boron. Let's see here. We have P-type. In the case of p-type, we have we have many silicons like previously. Silicon, 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 and silicon. Okay. In the case of p-type semiconductor, we have we have trivalent impurity. That means boron. Okay. Now these will be connected by the means of covalent bond. Okay. Now if I speak only about the boron, there will be a trivalent impurity. Trivalent impurity means there will be 3 electrons like this. Sorry, it's being bigger much. This boron, boron, and boron. And from silicon, we will be having one silicon will share here, one silicon will share here, one silicon will share here, and one silicon will share here. Okay, but see, for boron there will be a deficiency of electron, and that deficiency of electron is known as holes. What it is known as, this deficiency of electron, it is known as holes. So this part, this is nothing but hole. Okay, hole is nothing but it is a deficiency of electron. Now if I'm increasing the temperature, there will be the breakage of the bonds. And see what happened in this case, we were having crores of silicon, and in that crores of silicon we have doped lakhs of boron. So in this case there will be excess holes in lakhs, because we are adding lakhs of barium, sorry, we are adding lakhs of boron. So because of that boron, there will be excess of holes in lakhs. So because of the flow of hole also, there will be a current. Why? Because see, we have formula from current electricity. I is equal to NEAVD. If there is an increase in the number of charge carrier, obviously what current will increase, and only electron is not responsible for producing current, even the hole is responsible for producing current. Hole is what? Hole is nothing but the deficiency of electron. Okay, now this was about p-type semiconductor. Okay, now let's see about the n-type semiconductor. This was p-type semiconductor. Okay, this was p-type semiconductor. Okay, there was a silicon. See, yeah, that only they explain. There was a silicon, there was a three means that boron, aluminium, or else something we can write here. Okay, yes. Now in the case of n-type semiconductor, same what we have. We have silicons. Okay. Silicon, 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 silicon. And we are doping arsenic. Okay. Now, what in the case of n-type? N-type means there will be pentavalent impurity. Pentavalent means addition of means 5 electron in the valence band. So here, if I speak about arsenic, there will be one, two, three, 4, and 5. 5 electron, and it will be mutually shared by silicon. If we increase the temperature, there will be breakage of the bond, and because of the breakage of the bond, we will get lacks of excess electron. Okay, and that excess electron will be responsible for producing current in the case of n-type semiconductor. So this is how doping, that is trivalent impurity and pentavalent impurity, works. Okay, these are the theories of that n-type and p-type semiconductor. Okay, now we'll solve some question. We'll see some question based on this. First, we have, what is the primary characteristics that distinguishes metal from semiconductor? Waiting for the answer. I'm just giving 1 minute time. Let me know the answer, please. Waiting for the answer. Waiting for the answer. Okay. What is the primary characteristics that distinguishes metal from semiconductor? Primary characteristics, that will be electrical conductivity. Okay. Now, which material is commonly used as a semiconductor in electronic devices? And the options are aluminium, silicon, copper, or iron. Waiting for the answer. Waiting for the answer, waiting for the answer, waiting for the answer. Yes. So the right answer is, which material is commonly used as a semiconductor? The material is silicon. Okay, yes. Let's see the next one. What effect does increasing temperature typically have on the resistivity of material? Increasing temperature typically have on resistivity of material. What effect does increasing temperature typically have on the resistivity of material? Waiting for the answer. What effect? Yes, the answer is, what effect does the increasing temperature typically have on the resistivity of material? Resistivity of material will get increased. Okay, let's see the next one. Which category to material like germanium and silicon fall in terms of electrical conductivity? And the options are conductors, semiconductors, insulator, or superconductors. Conductor, semiconductor, insulator, superconductors. In which category material like germanium and silicon falls? In terms of electrical conductivity? Yes, it falls in the category of conductor, semiconductor, insulator, superconductor. Semiconductor. Okay. The next one. The question is from March 2023 for 1 month. Why an intrinsic semiconductor is doped with small amount of trivalent impurity? Why an intrinsic semiconductor is doped with small amount of trivalent impurity? Yes. If intrinsic semiconductor is doped with small amount of trivalent impurity, then option B, that it will become a P-type semiconductor. P-type semiconductor. Okay. No. Next, for extrinsic semiconductor, the question is, what result from doping germanium metal with a small amount of indium? What result from doping germanium with small amount of indium? Options are semiconductor that is intrinsic, the an insulator, an N-type semiconductor, a P-type semiconductor. Small amount of indium. First, think and tell me, indium falls in which category? Yes, group 13. If we are adding group 13 element, if we are having a group 13 element, then it will be p-type semiconductor. Okay, like that we have to remember. Indium means boron, gallium, gallium, aluminium, and then intrinsic, sorry, indium and thallium. So that indium will be for p-type semiconductor. Okay, let's see the next one. What is the name of semiconductor that flows current in a pure semiconductor crystal when crystal bonds break? And the options are acceptor, donor, intrinsic semiconductor, or extrinsic semiconductor. Waiting for the response. What is the name of semiconductor that flow current in a pure semiconductor crystal when crystal bond break? That will be known as pure semiconductor. Na? That means it will be intrinsic semiconductor.